All right, let's try this problem together. So after reading about the definition of resultant velocity, let's give a problem a try. If you're riding a bus traveling east at 25 meters per second, let's underline that, you stand up and walk down the bus's aisle at 1 meter per second east. Okay, so we know velocity has a direction, so let's include that direction as well. So they're both traveling east. What is your resultant velocity? So I posted a really good video. Professor Dave explains what reference point is, just to give you a better idea. So that's on my Weebly website if you want to check out what frame of reference is to help you understand what it means to have a resultant velocity. Sometimes resultant velocity is referred to as relative motion. So let's think of these two items, the person and the bus, both moving east. Now in relation to the Earth's surface, and you're standing back and you're watching this happen in front of you. So you're watching the bus go by, you're watching the person get up and move down the aisle, also in an eastward direction. So if you're standing back and watching this happen, it looks like the bus is moving 25 meters per second east. But what is the person's resultant velocity? So in relation to the ground, it should actually look like the person's moving even faster than the bus is moving. So what you do in these types of problems to find out the resultant velocity of the person, when two things are moving together in the same direction, in order to find the resultant velocity, you want to add the numbers together. So that the math is actually really easy, but trying to understand what resultant velocity is and reference frame over the Earth's surface, that can get a little confusing. All right, so as far as the math for this, like I said, we're just adding the numbers together. So we have, I'll try to write neat here, 25 meters per second east for a direction. Now for direction, it doesn't have to be as official as north, south, east, west. A direction to make a number a velocity could be up, down, left, right, forward, towards the school, away from my home. Anything like that could still be a direction. It doesn't have to be north, south, east, west, anything like that. All right, so 25 meters per second east for the bus is the bus's velocity, and then we have 1 meter per second east. Sorry, this is a little sloppy. I don't have a mouse here. Equals, so obviously some pretty simple math. We get 26 meters per second. Now that's just a speed unit. In order to make it a velocity unit, we'd have to add a direction. So again, go back to this whole scenario where you're standing back and watching the bus move to the east and the person move to the east. So the resultant velocity of the person is the person walking down the bus aisle still moving east, or has their direction now changed? So in these problems, again, really easy, add the two numbers together, and your resultant velocity direction is still east. Just because the person got up and started moving towards the front of the bus does not mean the direction of the bus changed. The person and the bus, everything is still moving to the east. There you go. So your final resultant velocity is going to be 26 meters per second east. Now the next problem I want you guys to try on your own. It's a little bit different than this one. Show all your work through Pear Deck so that I can see what you're thinking. So go ahead and give the next one a try. Write down your answer, and then the answer will follow after you show your work and go on to the next slide. All right.